Our drone is a highly autonomous fixed-wing drone that flies beyond visual line of sight. We have had two generations of drones here. One is Quail and the other is Robin. And we are very much bird inspired here internally. And so those are the names that we use here. But all the drones are called Zips. So I want to talk to you about the design of this drone. So the drone is pretty much designed to have line replaceable unit. And so the three main ones are the body, the wings, and the battery. So every single unit is apart, so which makes it easy in engineering and in technology. It makes it easy to change or innovate on one unit without really affecting the other unit. As you have seen, like the body has, this flight computer here, and then it has the two motor pods, yes. And then it has the wingtip and the two wings. And let me show you the front. So if you are here, you can see this is the front and this is the payload bay. This is where we put the package. And when it's about to deliver, how the package gets out, these fibers will just push the package out. And then the package will just come down and then it will reclose its doors, right? And so let me show you the battery. These batteries can last the drone for 2 hours. And so we don't need to power it on or power it off. We just, put the battery on the drone and then it's powered on immediately. So you see that this light is blinking fast. This light is blinking slowly-ish. This is just blue, right? So what happens is these smart chargers play two roles, right? They not only keep the power for the drone to fly, but they also keep all the information that the drone needs to fly. The drone will usually ask itself these questions: is where am I going? What am I carrying? What's the wind around me? What are the conditions I'm flying in? How do I behave when this happens? Yes. And all those informations are usually in here. When the plane returns back, we also take the battery that was there, we put it back here, and then the system will download all the information that the plane, encountered when it was flying. And we use that to evaluate the data and to improve the systems. Like, it's to improve how the battery functions, to improve the design of the plane. We improve everything about the plane.
What are the batteries made of?
The batteries are made of cells, Panasonic cells. Do you know the car's Tesla?
Yeah.
Yes, the car Tesla use the same battery cells that we use here. And so, these are the wings, and this is the third component of the wings. And each of these, there is a wing for each drone.
What are the wings made of?
It's carbon fiber. It's 3D printed carbon fiber. Yeah.
Okay.
Yeah. Yeah, so the drone is designed to be fault tolerant, so that's how we have two propellers and two air data sensors and so on. It's to help us to have redundancy for whenever one needs to assist the other, because for any reason one could have an issue and stop flying, and so the other has to take over. So what happens if all of this fails? So for example, let's say a major issue happens. Here we have a parachute landing on this side. And we also have, a parachute system where if for any reason it's unable to continue its flight path, the parachute system would just, deploy itself and allow the drone to land very gently. And so it's very, very safe in a way. But this happens very rarely. It's just in here, in case, but it really doesn't happen that much.
Did it ever happen?
No.
Okay.
We haven't seen it. So far it just flies, delivers blood, and then comes back.
That's good.
Yep. Thank you.